We're on to fractions today, and unfortunately, we're still not using a calculator. Tear. So, I know we all love fractions, so I know you're excited. Just kidding, fractions can be super difficult. That's why we usually don't like them. We're talking about adding and subtracting, though, like I said. So, we've got a couple notes here at the top before we just do a few examples together. Now, when you're adding and subtracting fractions, you must have a common denominator. And I know a lot of us already know that, but can't say it enough. You have to have a common denominator, which remember that's the bottom number. I have to remind you here. Numerator's on top, denominator's on bottom. The number on the bottom has to be the same before you can even start the problem. So keep that in mind when you're adding and subtracting. I'm going to say this to death, so I apologize in advance, but make sure that you always reduce your answer. Always. Okay, never give me an answer that's not simplified or reduced on a quiz or an exam. You will get points off. Okay, let's start off pretty basic. Number one already has a common denominator. The numbers on the bottom are both 2, so I'm ready to start the problem. Now, here's a mistake people will make. They'll say, oh, let's add 2 plus 2, 4 on the bottom. You do not change the denominator. That remains a 2. You only add the numerators. So I only add 1 plus 9 to give me 10. Second bullet point, you better reduce your answer. Okay, and by reduce, I mean just divide both numbers by what you can. Or if the top number is bigger than the bottom, it's just a division problem. So it's really just 10 divided by 2, which is simply 5. You can put 5 over 1, but if it's just 1 on bottom, just say 5. That's way easier, less writing. For example 2 is kind of where I got to start thinking about this denominator thing. So I see 4 and I see 2 on the bottom. We need to make them the same. You multiply to create a common denominator. Look to the smaller number. If I multiply this 2 by another 2, I'm going to have 4 on the bottom. Whatever you do to the bottom, you have to do to the top. The first fraction will not change. I'm going to kind of section my paper off here. Do that if it helps you too. The first fraction does not change. The second one will though. So that's going to be 1 times 2, 2 over 4. For my answer, I do not change the denominator. That stays a 4. I just subtract 3 minus 2 on top, which is 1/4. Those numbers can't be divided by anything besides 1, so I'm already reduced. Number 3, 8/5 plus 3. You need to make 3 a fraction before you start. And to do that, you put a 1 underneath it. Now I have to create a common denominator. If I look to the smaller number, if I just multiply this 1 by a 5, I'm going to have 5 on bottom. Whatever you do to the bottom, you have to do to the top. So it's going to be 8/5 plus 3 times 5 is 15/5. Okay, so denominator stays the same, that's a 5. On top, I've got 8 plus 15, which is 23. Ooh, this looks strange. 23 over 5. No, there's no number that goes into both of them, so I'm going to leave it. You can write it as a mixed number, but you don't have to. 5 goes into 23 4 times with 3 left over. So you could write it either way. I am totally okay with you leaving it improper though. Okay, number 4 is an example where I have to change both of the numbers on bottom. So I see 3, I see 4. I need those to match. I just do 3 times 4, and I aim to make them both 12. So I need to multiply the first fraction on top and bottom by 4, and the second one on top and bottom by 3. So the entire problem is going to look different. The first fraction will be 16 over 12, and the second one will be 15 over 12. There's a common denominator, so I can keep that the same on the bottom and just subtract the numerators. which will just give me 1 over 12. All right, couple more here. So number 5, ooh, they threw negatives in here. Don't you love that? I need to make the bottom numbers match, get a common denominator, and I'm just going to shoot for 45. So I'm going to multiply the first fraction by 5 and the second one by 9. To deal with this negative, you guys, I'm just going to take it and put it on top with the 4. Well, it's not going to be a 4 anymore, but whatever it is, I'm going to put it with the top number. When I multiply both numbers in the first fraction by 5, I'm looking at 20 over 45 minus, and you could use your hand trick for 6 times 9. 1, 2, 3, 4, 5, 6. So that's 54 over 45. Okay, so when I put those together on the bottom, that's going to stay 45. Grab your number line for this one, negative 20 minus 54. And if I were you, I would pause and I'd go grab my number line and try to figure that out, or just visualize my number line. If I'm all the way at negative 20 and I count to the left 54 places, I'm going to be at a massive negative number. And really, I'm just adding those two together, and it's going to land me at negative 74, which is a disgusting answer, but that's it. All right, number 6 here. Ooh, I don't have to change both. I can just multiply the first fraction by 2, and it'll become 2 over 8 minus 2 over 8. Same fraction minus the same fraction. Don't overthink it. That's just 0. Last one, I see 2 mixed numbers. So you can change them to improper fractions, which is what I would do. So remember, when you do that, get the outline of my problem going. The denominators don't change. So this one's still going to be a 3, this one's still going to be a 2. Here's how I figure out the top number. I do 3 times 2, which is 6, plus 4, 10/3. Is the same thing as 2 and 4/3. Over here, I'm going to do 3 times 2 and get 6, plus 1, 7/2. So here's my new problem, which is a little bit easier to figure out than the original. I'm going to go for a common denominator. I'm going to get them both to be 6. So that gives me what? 20 over 6 plus 21 over 6. Denominator stays the same. 20 plus 21 is 41. That's reduced, and that's my answer. See, fractions aren't that bad.